Thanks, Tanya. I'm Akshay. This is Poom. We're here from OpenAI, and we're here to talk to you about how we are using ClickHouse to scale petabytes of log data. So quick show of hands. Who uses ClickHouse for observability? I think about a third of the room. Now keep your hands up if you have petabytes of data in that ClickHouse cluster. And how much of that data is growing by 20+% month over month? Few of you. So this is the scale that we have at OpenAI. In fact, we are ingesting petabytes of data every day. Now, last night, I asked ChatGPT to help me contextualize what this even means. It said 10 petabytes of data is the equivalent of 500 Library of Congress's worth of books. I don't know what that means, but it sounds kind of wild, right? It's the equivalent of 2 billion iPhone photos. So if you're taking a photo a second, that'll take you 60 years, and we're generating this much data in a day. And it'll take a pallet of hard drives to store this amount of data. So the scale is absolutely mind-boggling. So I'll quickly touch upon the business problem and kind of why we chose to use ClickHouse. Poom will then do a technical deep dive in a couple of interesting problems we had to solve, and then we'll go and talk about what's next and what the future looks like. So what is a log, right? I have an example here. Should be fairly familiar to most of you. It has some well-structured fields like timestamp and trace ID. It also has a body, which is just textual data, maybe a status code. And as you can imagine, people will want to ask questions like, show me all the logs for this request ID, or group my logs by this status code, or even here is an arbitrary string, show me all the logs that contain it. So who is querying all of this data? OpenAI is a unique company where we are both a research lab as well as a product engineering org, right? We have a team of researchers who are coming up with the latest and greatest frontier models. We have ChatGPT, the consumer product that all of you are familiar with. And we also have an enterprise API that companies are using to build the future. Our researchers and all of these functions need observability to do their job, right? Researchers need high cardinality traces. They're training billions of models on millions of GPUs and want to know what's going on. ChatGPT is growing faster than any app I've ever seen, and more users means more servers, means more logs, and so our ingest needs to scale. And when you have a consumer app and an enterprise app, SLAs matter, right? And engineer gets paged at 3 in the morning, and something's wrong, and you need to use the observability stack to figure out what's going on. So why did we choose ClickHouse? ClickHouse is open source, so there's no vendor lock-in. We can look at the code when there are issues, right? It makes those things very convenient. It's horizontally scalable and cloud native, which means that it's relatively low operational lift to be able to scale it with both ingest as well as queries. It has flexible indexing support. So we have a wide range of queries, a wide range of use cases. We can turn on the indexes that matter and make queries fast. We can turn off the indexes that make ingest slow. And that flexibility is really important to being able to scale this thing. It's a SQL database. And our AI models and AI agents know how to talk SQL. So we can integrate AI into the observability stack, which makes for some super powerful features. And it's battle tested for this use case. As Tanya mentioned, and as all of you are familiar with, a lot of our peer companies are using ClickHouse for this exact use case. And that means there's a lot of good support, and it's just the right tool for the job. So with that context, I'm going to hand over to Poom to go deep on a couple of technical problems we've had to solve.
Yeah, thanks, Akshay. Spoilers. Before I go on, I just want to say that a lot of the things I'm going to be talking about today is by our teammate, Dalian, who isn't here because he's on vacation backpacking through Europe. But with that said, let's set the stage a little bit. We run a log management system, and that means we have software like Fluentbit running on every machine, tailing container logs and shipping them to ClickHouse. We, at the time, have a single ClickHouse instance with 90 shards, and every shard has 2 replicas. Now, because 80% of our user queries only look at the data generated in the last 2 days, we put that on disk and put everything else in blob storage. ClickHouse, being cloud native, intelligently abstracts away this tiered storage structure from us, and writers of SQL never have to care where the data lives. So with this setup, things were running pretty smoothly. People wanted logs, and we gave it to them. That is until March 25th of this year, OpenAI launched image generation in GPT 4.0. And our users loved it. They were generating pictures of themselves in an anime style, pictures of memes, pictures of the OpenAI logo, but as a steak, pictures of famous events. And personally, I saw one of the biggest user growth I've ever seen over such a short amount of time. And all of our servers were melting. Now, in our side of the house, we saw log volume grew 50% overnight. And we went to bed, comforted by the knowledge that we had 50% headroom in CPU utilization, and woke up having to grapple with the fact that that was wiped out in a single night. Oh no. Well, at this point, ClickHouse is very unhappy. It was giving us out-of-memory errors, replications lagging behind, and all the metrics that mattered didn't look very good. And we know we had to control ingest and scale up ClickHouse somehow. So we did that. We had 2 query replicas. We spun up a third, made it query only so that expensive queries don't interfere with ingest. We got a breakdown of our logs by service, cluster, container names, by every cut we could think of, so we could find things to sample, and we sampled them. But ultimately, that wasn't enough. So we decided to drop onto a machine and started profiling ClickHouse. Now, I know I've been on this slide for a while, but one thing to know is that when ClickHouse ingests new data, it puts rows into groups and builds indexes on each group to speed up future queries. And one common type of index is the Bloom filter, which helps quickly tell if a value might be in a column without needing to scan every row. So if a user says, find me all the log lines for this request, ClickHouse can skip scanning entire blocks of data if the Bloom filter says, this request ID definitely isn't in these blocks. Well, you probably see where I'm going with this. When we got the profile, one stack trace showed up at the top. ClickHouse is spending more than 50% of its time building Bloom filters, and we were very curious. So, and very much we wanted to go and take a look. So we did. What I show you here is the actual source code for ClickHouse, in the ClickHouse code base for building Bloom filters. And a Bloom filter is a very simple data structure. It's a bit array, and to add something to it, you hash the element, use the hash to compute the position of the element in the bit array, and then you flip that bit to 1. And well, there are a bunch of places where this could be slow. We have hashing, and we have, random array access. But according to our profile, the thing that was slowest was this. A single division instruction that the compiler couldn't optimize away. Now, for those of you who are familiar with CPU instructions, divisions are 30 times slower than additions and bitwise operations. So it's not a big surprise that this thing is slow. What we realized is that we're dividing by the same number over and over again. Every time we add an element to this Bloom filter, we divide its hash by the size of the array. And one cute CPU trick you could do at home is you can approximate divisions with multiplication and bit shifts. As long as you know what number you're dividing by beforehand, you could compute how much you have to multiply by and how many bits you need to shift and get the exact same operation. So we did just that. We made almost a one-line change to this function, patched ClickHouse, and deployed it. And we saw immediately a 40% reduction in CPU usage. And one could also say that this was a time series of my heart rate over the period of that incident. But yeah, well, before Dalian went on his backpacking trip, he upstreamed this change, so this will be available in the next version of ClickHouse. And all this is to say that none of this would have been possible if ClickHouse wasn't open sourced. With this, I'm going to pass it back to Akshay.
Awesome. So yeah, I think that just goes to show that the cloud nativeness and open sourceness of ClickHouse really saved us when we were in a pinch. So what's next? Our work is nowhere near done, right? Hardening ClickHouse, scaling it continues to be a challenge. In fact, concretely, today we very naively fan out queries to all shards. We're kind of hitting the limits of that, and so we need to do better here. I'd actually love to chat with folks if you have experience here and brainstorm how we can solve this at the scale. We're constantly improving the UX and tools we provide in the observability stack, right? We want to build performance monitoring and other things for engineers to do their jobs even more effectively. And we want to integrate agents into our observability stack. Imagine agents being able to handle alerts or diagnose alerts before you even have to, right? So we're kind of building all this, and ClickHouse enables us to do it. So if any of this sounds interesting to you, we are hiring. There's a QR code up here. Feel free to scan it. Poom and I will also be around in the AMA section or wherever to chat, answer questions. So yeah, thanks so much.